Okay, let's have a look. So, looks confident. First thing, because we talked so much about missing equal signs, I'm just going to highlight those, and then later in this paper I think we'll see the same as the last paper, that when it's a easy question, missing equal signs, missing pieces of information don't really make a big difference, but later when the questions get more tricky, they do, and they confuse what our brain's ability to understand what we're even doing. So that's why they're really, really important. So on this one, you have got square root a cubed times square root 16a, and then it should be equals this, which equals this, which equals this. Look at the next one. 4b to the 6 all to the 5 over 2 equals this, which equals this, which equals this, which equals this. So I know it seems like a really small thing, but when there's a blank space where you know what you mean, your brain knew what you meant, don't think of it about communicating with the examiner. Think of it as communicating with your future self in a few seconds, who will see that space and not remember why there's a space there, and then will invent a space filler. Sometimes that space filler is going to be wrong. Okay, other than that, I've just noticed one other thing. This is a really good example of where the answer is correct, but you wouldn't get full marks because there is a mistake in there. Something you've written in there is not true. Can you see what it is? Okay. So hard to find mistakes. So hard, because we read what we wrote, or even what somebody else wrote, and we just think, yeah, that's that, yep, that's that, yep, that's... Okay, I'll put you out of your misery and tell you. So the square root of 16a is 4a. That is true, because it's the square root of 16 times the square root of a. Oh, wait a sec. What's happened here? This isn't true, is it? Even I didn't spot this one, first of all. Square root of 16a. See how... Okay, let's go one step at a time here. First of all, what happened is this little square rooty sign got a bit smaller. You see how it's the square root of 16a there, and now look, now here's a little invisible bit of square root. Now what does that tell our brain? Our brain 1 second after we wrote this, when we wrote it, we knew we meant root 16a. Now our brain goes, what was it you were saying? Root 16a? Root 16a is 4a. That is true. But that's not what we were asked for. We were asked for the square root of 16a. So that little bit of invisibleness there, where you know what you meant, of course you knew what you meant, but you 1 second later didn't know what you 1 second ago meant, and just read it and then wrote down exactly what it was. Now, luckily you now sort of ignore that thing that you've written. So now we are changing. Look what's happened here. This bit says 4a all square rooted. So now what you're writing is this. Now that is not the same as 16a all square rooted. Now we go from here to here. Now that's also not true, because if you have the square root of 4a, that would equal the square root of 4 times the square root of a, and the square root of 4 is 2, not 4, so this does not equal this, and this does not equal this. They're not the same. They're not the same. You knew what you meant. I know you can do this easily, very easily. But this is what we need to focus on to get your grade to move up. It's all of these little subtle things where what you're writing isn't what you're thinking. That's what we need to deal with. We'll come back to how to actually fix this in the next bit. So let's look at the next one. That equals root... Oh, I see. So you've applied the square root to the 4 and to the b over b to the 6. So there's the square root applied, then there's the 5s. Then we've got b to the 6 all to the half. We should have some brackets here, really. It doesn't make sense to say b to the 6 to the half, because it looks like you mean b to the power of 6. Oh my god, b's and 6's look the same. B to the power of 6 to the power of a half. It looks like you mean that. And you don't. You mean that. You know what you mean, but it's not what you've written. And then 6 times a half is 3. What on earth is happening here? This is 3. Here's the 5. Now we're still over the 2. 32. 30? Does that say 30? Ah, I see. Okay, so we're doing B to the power of 6, all to the power of a half, all to the power of 5. And what you've done is to switch the half and the 6. And then multiply together the 6 and the 5. That's okay. To make 30 over 2, which is 15. And then it looks like it's coming together at that point. Okay, so again, a little bit of confusion creeping in here because of the way that you're writing the notation, but I think again, like the first one, it's probably worked out fine. Just need to check the mark scheme, but some places where the marks would get lost.